Welcome to the How to Program with Java podcast, where all you need is the desire to learn, and you too can become a Java programmer with absolutely no knowledge of programming. And now, your host, Trevor Page.
Good afternoon, good evening, good morning, whatever your case may be. Welcome to this episode of the How to Program with Java podcast. We have hit episode number 45, which is fantastic. And in this episode, we're going to be continuing our sort of deep dive into the SQL world. More specifically, we're going to be getting into the nitty-gritty of creating the remaining relationships that we have to create within our actual databases. So we're going to be talking about more actual sort of SQL scripts that we're going to be diving into. And like I said, we're going to be tackling the many-to-many and the one-to-one relationships. If you have no idea what I'm talking about, if this is your first time listening, I would recommend you maybe go backwards a little bit. We've been talking about SQL and more specifically MySQL for the past few episodes, but this is the How to Program with Java podcast, so obviously if you go all the way back to the beginning, you will learn all about Java. We just happen to be talking about SQL right now because it is, I find, a very crucial aspect of the programming journey. Okay, the plethora of things that you need to know to be a really good programmer and really well-rounded programmer. Okay, this is just what we're talking about at the moment. Of course, we're going to be eventually taking this into back into Java, where we can marry our knowledge between Java and SQL into using frameworks that we can use to actually build databases inside of our Java code and interact with that inside of our Java code as well. So being able to insert directly into the databases and querying from the databases within our Java code, and obviously putting it all together in a nice, neat little package. But for now, we are on the SQL journey, and we're learning about, like I said, the many-to-many and the one-to-one relationships and how to actually create that and enforce it. That's the key here, is enforcing the relationship automatically inside of our database. So that's what we'll be diving into today. But first, before we dive into that, I'm going to jump back to the 5-star rating. So if you leave a 5-star rating / review for the podcast, I will go ahead and read it at the beginning of every single episode, or whichever episode that I happen to read it on. So for this week, we've had 2 new 5-star reviews come in, which is fantastic. One from a username that looks like someone's actual name, but they only signed it T, so I don't know if they would want me to read their actual name. In any case, this particular person, let's call him T, is from Ireland, and he said that he's doing a postgrad in computer science, and though he's more interested in databases and SQL, in particular NoSQL, he has a compulsory module in Java programming. And it is not his strong point, to say the least, but these podcasts have helped him enormously in building his understanding for a lot of concepts that he deals with in class. So if at all possible, he's asking if I could do a podcast on Java GUI development, in particular the Java Swing suite. A good question, and I sort of tiptoe around the Java GUI talk, mostly because, I don't know if I've said this before in the podcast, but I learned about the Java GUI stuff, the graphical user interface stuff, in university, but to be honest with you, it's something they forcefully sort of cram down your throat in university, and I don't really, there's not a huge application that comes along with it. There's not a lot of benefits that come from learning that stuff, just because most applications these days are not built on Java GUI stuff. They're either built with an Android device or a BlackBerry device. So the front end there, the actual GUI, is built into the phones itself. So that doesn't use Swing. Swing is sort of like a framework that goes into Java that allows you to create these graphical user interfaces. Or you're going to see Java inside of web pages. And in web pages, again, you don't use Swing, you use HTML and CSS and JavaScript to create your interactive website. So there's not a whole lot of practical applications for Swing, but I definitely know that a lot of people, I shouldn't say a lot, probably a handful of people have asked about it. So I should probably put together some tutorials on it because people are obviously wanting to learn about it. But I will always preface it with saying, this is probably only going to help you in school. You'll probably never actually use this in the real world, except for the one person who reached out to me to say, hey, I actually do this full time as my job, so you shouldn't be bashing Swing, which I apologize for that person. Obviously, if Swing is part of your full-time job, then you're going to feel like it is very important. So, any case, for Mr. T, let's call him, from Ireland, sure, I will put together a Swing episode. I guess I can do it as a podcast, and maybe even it'd be better to do it as a video series. So maybe I'll put together a video series for Swing. Hopefully I can do that in the near future. I've been very, very busy lately, but I'm getting back into the swing of the programming thing, so hopefully I can put that together in the near future. So by all means, this particular person, T from Ireland, reach out to me directly. You can hit me at info@howtoprogramwithjava.com, and maybe just remind me if you haven't seen anything about Swing. Just say, hey, Trevor, remember I'm that guy from Ireland who said that he wanted to learn about Swing. In any case, moving on to the second 5-star review. This comes from India, which is wonderful. I love getting reviews from India. The name is, oh boy, I can never get these names right. Kemparaj. Don't know if I wrecked your name. I apologize if I did. I gotta stop saying that, because let me just say once and for all, maybe now, for the future, for all the rest of the episodes, I will apologize for myself for all the future episodes if I mispronounce your name. I'm deeply sorry if I do. So there you go. That's my apology for all the rest, so I never have to say that again. So from Kemparaj from India, they say the best podcast ever for beginners and a very encouraging one. Please keep it going. It's an amazing podcast. I have lots of love and fun learning. God bless you. Fantastic. So, thank you very much. I love getting the love from India and all over the world. Ireland, in the UK, obviously in the US, from Canada. There's been reviews coming in from all over the planet, which is just so bloody cool. Australia, New Zealand. I'm so happy to have this kind of reach and to be able to help you guys out. It's really what I truly love doing, and I just love doing it day in and day out. I can't get enough of this stuff. So, cool. So, let's move on into the actual meat and potatoes of the lesson for today. So like I said at the beginning of the show, we're going to be talking about actual scripts, so actual code that we're going to be writing to create our many-to-many and one-to-one tables and relationships, as well as having it automatically be enforced by our RDBMS, our Relational Database Management System, because that is what the underlying system is. That's the engine that drives all this forward, and it allows you to enforce the rules that we're creating that establish these relationships. So let's dive into it. First on deck, I'm going to do let's do the many-to-many relationship, because that's more or less a fairly common one. So in the many-to-many relationship, just to give you a quick refresher, what does that look like? What does a many-to-many relationship look like? Well, one of the examples that I pointed out in an earlier episode was the relationship between authors and books. Okay? Authors and books. One author can create or write or author many books. That's correct. Would you agree with that? One author can make many books. I'm hopefully going to be releasing another book in, again, a quote-unquote near future, which who knows what near future is. I really need to set a deadline for myself, so I stick to it. But I really want to write a book on HTML. I really want to write a book about JavaScript and so on and so forth, and take all this knowledge that I'm putting in this podcast and turn it into written form so I can get that into your hands. So I'm going to be an author who is the author of many books. So that situation holds true. That is a possible real-world scenario. Now, what about the other way around? Can a book have many authors? Well, absolutely. I'm sure you can go on, Amazon or browse your local bookstore. You'll see, if you flip the books over, on the back of the book, there are some that have several authors. A lot of computer science books, like textbooks, ones that are, 500 pages thick that you never get through the whole thing, those are often published by several authors. Several people have several different talents that can all culminate into one book, and they throw it all in there and sell it. So that relationship is also true. You can have a single book that has many authors. So when you have an author that can have many books and a book that can have many authors, you have a many-to-many scenario, okay? One author can map to many books, and one of those many books can map back to many other authors, right? Pretty cool stuff. Let's say, what's a real world scenario for that? Let's say I author a book on, well, let's just say on Java, okay? But I co-author the book with another person who puts in their expertise with respect to, I don't know, let's say Android development, because Android development goes along the same lines as Java, obviously. So let's say I co-author a book about Java and Android development with another person. Let's call him John Doe. So me and John Doe author a book. So what would that look like in our database? Well, there would be two authors in our database. There'd be Trevor Page and John Doe, right? There would then be one book, right? One book is, let's call it How to Create Android Apps with Java or something like that. So that's the book. So both of us would map to that one book because we're both the author of that one book. But let's say there's a second book. There's the How to Program with Java book, which is what I authored on my own, right? So now there's going to be a second book in the book table that's going to point back to me as an author. But remember, I was already an author on another book. So you see how the lines kind of get crisscrossed with a many-to-many relationship? It kind of turns into this, kind of crazy spaghetti situation. But it's a controlled spaghetti situation. It's a good thing in this case because you are able to map these sort of complex relationships using these tables. So there's your refresher course on what a many-to-many relationship is all about. But now I want to talk about how we actually create that in our database. So in the last episode, we talked about the syntax around creating tables. You say create table, you give it the name of the table, then you open your round brackets as opposed to curly brackets that we use in Java coding. We use round brackets or round, what are they called? Parenthesis, there we go, or parentheses, depends on how you like to pronounce it. These are parentheses that you use, the round ones. So we open and close those, but inside of those, we give the information about the table. Okay, so you give the columns, the actual data that's going to be, or not the data, sorry, would that be the metadata? I'm not sure. It's the columns that describe the data that's going to be going into this table. So, without making this more confusing than it needs to be, let me just talk to you about what the author table will look like. So we will say create table author, open parenthesis, then we will give it the primary key. So the primary key is going to be author ID. Okay, we want to have an author ID inside the author table. Author ID, we give it a data type, which in this case is int. We use our parenthesis to say 11, int 11. I described what that number was in the previous episode, but it's really kind of inconsequential. It's all about the display width of the data itself. If you need to have any padding, any like padded zeros in front of it, then that's where you use this number. But that's sort of the default. That's what goes into it. So that's what I'm using in my examples. Then we choose to make it an auto increment field because this is going to be the primary key, and we want it to automatically increment when there's a new row that gets inserted into that table. So when we put in a new author, then boom, it automatically gives it a unique primary key, a unique identifier that will obviously uniquely identify that particular row of data. All right. So then we have, then we put our primary key, because we need to define it as a primary key. The author ID is going to be a primary key. Then we put a comma, then we put first name. First name, we do first underscore name. Just like the author ID, like I said before, it has to be author underscore ID. We never have spaces in our column names. Just like having a variable in Java, you don't put a space. It wouldn't make sense to have a space in the name. So we have our first name, and then we define the data type, which in this case is just a varchar, which is kind of like a string that we use in Java. We put varchar, and we give it a size. So this one is 20. I arbitrarily chose 20. If your first name's longer than 20 characters, then in this case it wouldn't work in the database. So you'd have to sort of expand the size of that field. But I'm not worrying about those sort of edge cases right now. I'm just sort of obviously wanting to teach you the syntax. So then we have a comma, and then we put in our last name. Again, the last underscore name, and it's a varchar of size 20. And the 20 we obviously put in parenthesis, okay? We always have the brackets around our numbers when we are assigning like the width or the size for a particular data field, okay? Cool. So let me close, obviously, we close our round bracket that we had opened before for the entire table, and we put our semicolon to say that we're done for this particular piece of the script. So there we go. We've created our author table, okay? Again, just to look at that again, the author table has 3 columns: author ID, first name, and last name, where the author ID is the primary key. So, fantastic. Now what do we do? Well, remember, we have the author table and we have the book table, and there's a relationship between the two. As of now, we haven't seen a relationship just yet because all we've created is an author table with just information about the author. There's no information about a relationship just yet. So now we go and we create a book table, all right? So the book table is going to have all the stuff that relates to what would be in a book, or what we would want to use to find more information out about a book. So we create a table. Same syntax that we've always seen. It's just create table book, right? Makes sense. Open our round parenthesis, and then we give a book ID. So one thing that you might realize here, one thing that you might see as a trend, is we always have an ID for every single table. That's very, very important. I've said that before, but I'll stress it again. Every table needs to have an ID. Every table needs to have some way to uniquely identify any particular row in that particular table. Always, always, always needs to happen. It is very important to be able to uniquely identify a particular row of data. Cool? So we have, in this book table, we create the book table, and we want to create the columns. So we're going to have 4 different columns. The first one's going to be book ID, like I said. No different than all the other ones. We're going to make it an int size 11, so the 11's in brackets. We make it an auto increment, which obviously means that it will automatically increment our primary key ID any single time that there's a new row being inserted into this table. And we will call it the primary key because that is the primary key for the book table. Cool. So now we put a comma and we go to the next column. Next column is going to be the book title. So this is where it will be, the title of the book, How to Program in Java, or whatever the case may be for whatever book title you may create. So it's book_title. And then we make it a varchar because you can have letters and numbers in here. And let's make it 255 characters in length because, who knows how long your book title will be. 255 just seems like a good number to choose. Okay, cool. So it's varchar 255. We put our comma. We go to the next column, which is going to be the ISBN. Now, the ISBN is sort of like a uniquely... it's a code that uniquely identifies each book. It's kind of like a UPC number, I think. So each book will have a unique ISBN. For this one, I forget how wide a varchar or how wide an ISBN should be. If I sort of peek into, I've already sort of done up a little bit of this already in terms of creating the data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like I chose 10 to be the size of this field. So let's put it, make the ISBN be a varchar of size 10. Fair enough. If it's more than that, then I apologize. I don't necessarily know what the proper length of an ISBN is, but whatever. Again, it's just for teaching purposes. Okay, put our comma, and then we create the version code, because maybe there's a few different versions of the book for some reason or another. So I just threw in a version code, and for this one, we can make it an int. It's this version is going to be a number. It's never going to be a letter. So we'll make it an int, and we'll call it again size 11. All right, cool, fair enough. So there, now we've created the book table. So we've created the author table and the book table. But one thing, if you are a keen listener, you would have realized that there's, again, no identifying marks for a relationship between these two tables, all right? The relationship that is most common is the one-to-many, but that's not what we're using here. We're not doing the one-to-many, we're doing the many-to-many. If we were doing the one-to-many relationship, then you would have seen an author ID inside of the book table, all right? But you don't see that. So at this particular point in time, there's no relationship defined. So then where the heck is the relationship, right? We're so used to putting, ID fields into another table where they sort of don't belong. I shouldn't say that they don't belong there, but they're there to establish a relationship. So where is that information? Well, when it comes to a many-to-many relationship, what you do is you create another table. So a whole nother third table just to store the relationship information, okay? So that's what is unique to the many-to-many relationship. So we're going to create a third table, which we're going to call the author_book table. Author book table. And we name it that way because it's going to be establishing the relationship between the author and the book table. So what better name to use than author_book? So let's create that table. Now all this table is going to have is going to be essentially two columns. That's it. It's going to have two columns. One's going to be the author ID and the other one's going to be the book ID. So the author book table is able to, any given row of the author book table will be able to tell you any relationship between the author and a book. Any relationship between a particular author and a particular book. Or several relationships if they happen to exist inside of that table. But that's the key, is being able to see one row and saying, okay, for this row, what's the relationship look like? In any case, if you don't get that, you'll get that in a second when I go more into the examples later after we talk about the actual syntax for creating this particular table. So let's create the author book table. So this is where the relationship is stored and created. So we say create table author_book. Nothing new here, nothing fancy. We open our round parenthesis and we say author ID. Okay, so that's the actual author ID is now, it's not going to be the primary key, but it's related to a primary key that exists elsewhere. So we'll say author ID. We still need to give it a variable type, so we need to say int, and again in brackets 11. But then that's it. We're not going to assign an auto increment. We're not going to call it a primary key. And the reason why we don't do that is because it is not a primary key anymore. Remember the definition of a primary key. A primary key is something that can uniquely identify any row in a given table. But in this case, this is not going to be the case for this particular column because we don't want it to uniquely identify one row. We want it to be able to identify several rows because, like I said, we have a many-to-many relationship. So there's going to be many different potential relationships between each of these fields. So for example, if I happen to be the author of two different books, then I'm going to have my author ID appear twice inside of the author_book table. And again, if you're not grasping that just yet, that's okay. We're going to go into some real examples. Plus, you're going to be able to see the show notes. Again, I should mention the show notes at howtoprogramwithjava.com/session45. You'll be able to see real examples, real code, and you can actually take it and run with it and create the tables yourself and play around with it yourself. So you'll hopefully be able to really grasp it and understand what's going on here. So the important thing to note is that this is called a join table. I don't know if I mentioned that before. The join table is the author book table, where it joins both the author and the book tables on their own with this third table, which is the relationship between them. So this is called a join table. So our author book join table, and any join table that you create, never has a primary key associated inside of that table. And the reason being is because we have two keys that are being put together that are able to uniquely identify a given row. So that's no longer called a primary key, that's called something else. And I don't really want to get into that right now because that's a little bit outside of what we're talking about right now. But the key to making a database table work is being able to uniquely identify a row of data in some way, shape, or form, whether that's by using one column or by using many columns. Okay? In this case, we're using two columns to be able to uniquely identify a single row of data. But let's not worry about that right now. So, the most important thing is in our join table, we don't assign primary keys. So we just say author_ID, and we say int 11. There you go, that's it. Comma. And we put our second column, which is the book_ID. Again, it's an int with size 11. Cool. And we put a comma. So there's no fancy stuff going on here. There's nothing crazy that we're doing in creating these two columns. The craziness comes now, if you will. And it's not really that crazy because you've seen this code before. So what is it that we've created here? We've created two columns, but what are these two columns of data? The author ID and the book ID. What are they? They are foreign keys. Each of them on their own are a foreign key. And they're called a foreign key because they're a key that belongs to another table. Okay, it's not a key for this table, it's a key for another table. So we need to establish that relationship. We need to say that they are foreign keys that belong to another table. Okay, so now we create that code that will enforce that relationship. So we will say foreign key, and the first one we want to talk about is the author ID. Now, don't make the same mistake I did. Every time I type out this particular line of code, I always forget to use the brackets, the round brackets, and I always get compilation errors because it says that the code is incorrect, and I always have to scratch my head and do a Google search. So it's foreign key, and then you open a parenthesis, and you say author ID, author underscore ID, and you close the parenthesis. So you're saying, okay, what is my foreign key? My foreign key is the author ID, and then where does that foreign key exist? Or rather, where does the primary key exist outside of this particular table, outside of this join table, this author book table? So we say references the author table. So we say references author. And then in brackets, we put the column name of the primary key of the author table, which is author underscore ID. So to recap that entire line of code, and like I said, you've seen this before. We did this in the last episode. This is no different from what we did in the last episode. But to recap, it is foreign key, open bracket, author ID, close bracket, references, author, open bracket, author ID, close bracket. Okay, it's a lot of words. I know it doesn't come through in audio very well, but you'll see the example on the show notes page. So great, we've done the foreign key for the author ID, but we're not done yet. Remember, we have two different foreign keys in here, so we also have to establish the relationship for the second foreign key, which is the book ID. So we put our comma, and we start a new line of code, and we say foreign key, book ID this time. Again, the book ID is in brackets. References book, open bracket, book ID, close bracket. There you go. So we've created two columns in our join table, the author ID, the book ID, and we've assigned them both to being a foreign key pointing to the appropriate locations that they should be pointing to, which is the author table and the book table and their respective primary keys of each of those tables. Okay, so now we're done. So now we've created our three tables, and we have properly established our many-to-many relationship in our database. All right? So now we can go crazy and we can start inserting information into these tables. And I have examples that you can see, again, on the show notes page, howtoprogramwithjava.com/session45, and you will see the examples. But basically what I've done here is, the first thing you need to do is you need to insert the data for the authors and the books. Okay, so you need to get author data and book data first, before we establish a relationship. Right? Because there can't be a relationship that exists between the two tables if you haven't yet created the data. That wouldn't make sense. So we need to create the data first. So like I said, let's create some authors. Let's create Trevor Page as an author, first name, last name. Maybe, Jane Doe and Jack Johnson, for example. Those are the three names that came to my head real quick. So Trevor Page, Jane Doe, Jack Johnson. So we insert the three of those pieces of data. Now, remember, when we do that, because the author table has the auto increment defined on itself, it's going to automatically assign an author ID to each of those authors. So author ID 1 is going to map to Trevor Page because I inserted him first. Author ID 2 will map to Jane Doe because I inserted her second. And author ID 3 will map to Jack Johnson because I inserted him third. Make sense? If I were to insert another person, then they would get ID 4, and then 5, and then 6, and so on and so forth. Okay. Ooh, one thing to note, I don't know if I've said this before. If you delete an author, so let's say I insert Trevor Page, Jane Doe, Jack Johnson, that's 1, 2, 3, and then I delete, let's say, Jack Johnson, number 3, and then I insert Jack Johnson again. So if I delete him and then insert him again, what do you think happens with his ID? Do you think it puts it back to 3? Or do you think it increases it to 4? Very good question. I would never have known the answer unless I played around with it way back when I started fiddling around with databases. The answer is it always increments the number. It never tries to roll back and figure out what the minimum ID is and map it back to that, or there's none of that craziness going on. It follows one rule and one rule only. It always increments based on whatever the latest increment was. So if you delete Jack Johnson and insert him again, Jack Johnson will now have author ID 4, not 3. All right? And then if you insert another person, that's 5. And then if you delete every single row in the table and insert another person, that's going to be 6. Okay? It doesn't try to go back to 1 because you deleted everything in the table. It just keeps on incrementing. Little side note. Okay, so we've inserted Trevor Page, Jane Doe, Jack Johnson. Authors ID 1, 2, and 3. So now we want to insert books. So here's some names of some books that I came up with, again, off the top of my head. So we insert into book, we say How to Program with Java 2nd edition. We give it an ISBN. Again, this is just a random, unique code that you can assign to a book. I won't say what it is here because it really doesn't matter. And I put in a version, which in this case is 2 because it's the 2nd edition of the book. All right, cool. That's going to be book ID 1. How to Program with Java 2nd edition is book ID 1. We insert another book. Let's call this How to Program with Java. Let's give it the version ID 1 because this is the 1st edition of my book. All right, cool. So that's book ID 2 now. I switched it around for you on purpose. So 2nd edition is ID 1, 1st edition is ID 2, just to shake things up, make your lives a little bit more difficult. So then we insert a 3rd book. 3rd book is Cooking for Dummies. Fair enough? Fair enough. So we insert Cooking for Dummies. Let's call it version 1. Again, the ISBN doesn't really matter. That's going to be book ID 3. And we put in a 4th book, How to Play Guitar. Let's call this version 3. Let's say that, that had 2 previous versions, but they're just not in our database right now. Fair enough. How to Play Guitar, book ID 4. Boom. Okay, so we've got our data, authors and books, but there's no relationship data yet. All right? Why is that? We've only inserted data into the author table and the book table. Remember, with many-to-many relationships, there's a 3rd table called the join table. So we need to insert data into that join table in order to establish our relationship. So that's what I'm going to do now. I'm going to insert data into author_book table. Okay? And remember, there's only 2 columns in there, author ID and book ID. That's all it wants, just the IDs. It doesn't need any fancy names or ISBNs or anything crazy. It just wants the primary keys. So we're going to insert them. So in this case, in this example, I don't think it'll be helpful to really talk about what numbers, the individual IDs that I put in, because it's probably a jumble in your head right now. But basically what I did was I assigned the IDs that represented the relationship. So since I know that I published the first 2 books, How to Program in Java 2nd edition and How to Program in Java, I know that I need to establish that relationship in my join table. So I need to say that author ID 1, which is Trevor Page, maps to book ID 1, which is How to Program with Java 2nd edition. So I insert values 1, 1. I also insert values 1, 2 because author ID 1 is Trevor Page, and he maps to book ID 2, which is How to Program with Java. All right? So I insert 1, 1 and 1, 2. I also insert 2, 3 because I said arbitrarily that Jane Doe was the author of Cooking for Dummies. Okay, Cooking for Dummies was book ID 3, Jane Doe is author ID 2. So I insert into author book, where author ID and book ID is 2 and 3, respectively. And then I insert 4th row into author book, where author ID is 3 and book ID is 4, because author ID 3 is Jack Johnson, book ID 4 is How to Play Guitar. And there you go. So I also have a select statement that I make, and I won't talk about that right now because it contains some sort of complex stuff. But basically, you can select the information now and look and see which author maps to which book. So when you select the data from the database, it will naturally just say, okay, here it is. Trevor Page maps to these 2 books, Jane Doe maps to this 1 book, and Jack Johnson, maps to this 1 book, and everything is hunky-dory and good to go. So, took me 35 minutes to explain all that. That took a little longer than I thought it was going to, but let's keep right on going. Maybe it's time for a little break. Maybe we take a break. Maybe we have a sip of our drinks. Maybe we pause the podcast and sort of, let our brains, percolate, let the information bounce around in there before we continue going to the second part. All right, so the second part is all about the one-to-one relationship now. All right, so again, to refresh your memory, one-to-one means there is a one-to-one mapping and can only be a one-to-one mapping between two different tables. So the example I had for this one is a person and a driver's license. Okay, one person can have at most one driver's license, or a person can have no driver's licenses, whatever the licenses. That sounds better. One person can have either 0 or 1 driver's license. Sound right? Sounds right. You can never have 2 or more or whatever. That doesn't make any sense. At least not in where I live. That's generally you don't have 2 different physical pieces of ID when it comes to your driver's license. You only can have 1 and 1 only, and there you go. So, all right, fair enough. And what about the reverse of that relationship? Can there be a driver's license that exists without a person on it? Well, I'm going to say no. I'm going to say that relationship doesn't make sense. There can never be a driver's license that would exist, like a driver's license number, where it doesn't map back to an actual person, right? So if the person never existed, then they cannot ever have a driver's license for that particular person that doesn't exist. It just wouldn't make sense, right? So that is the one-to-one relationship in a nutshell. That's exactly how that works. But then how do we establish that as a relationship inside of our SQL code? Because that's exactly what this episode is all about. And the last one was all about. It's all about writing the SQL script to be able to enforce that relationship. So how do we do it? Well, we have to create 2 tables. So this one, the one-to-one and the one-to-many don't require a third table. You can use it, you can create the relationship just using the existing 2 tables. Whereas the many-to-many relationship, which we just talked about, has to have 3 tables to establish that relationship. Okay, again, I'm just reinforcing that same piece of knowledge again because obviously it's important, so that's why I'm reinforcing it again and again. All right, so we have the one-to-one relationship is what we're talking about. So we have the person and the driver's license tables. So let's create those. So we say create table person. At this point, you should be pretty familiar with creating tables. And I don't think there's anything. Let me just scan through and see if there's any surprises here. It doesn't look like there's any surprises coming up, except for maybe a new data type. But I mean, that's just a new data type. You guys can handle that, I'm sure. So there's no surprises here. We just say create table person, open bracket, person ID. So again, we have a primary key identifier for this particular table. Person ID, int 11, auto increment, primary key. Okay, I'm not going to go into all this the semantics of how that should be spelled out and typed in, because at this point, hopefully you're getting a little bit more familiar with the syntax. Okay, comma, first name, varchar 20, comma, last name, varchar 20. Boom, we close the table bracket and we put our semicolon in, and there we go. That's the person table. Very straightforward. You've seen it many, many times already. Cool. So now let's move on to the driver's license table. Create table, drivers _ license, open our round bracket. Now here's where it gets interesting. You might expect me to say driver's license ID, right? Because we have a driver's license table, so it would make sense to have the primary key as being the driver's license ID. Okay, that's exactly how we've done it in every single other table that we've created. But this is where the curveball gets thrown. So in order to enforce a one-to-one relationship, we don't create a driver's license ID. So the primary key of the driver's license table is not the driver's license ID. We never create that. What we do to create this and enforce this one-to-one relationship is we create the driver's license table and we make the primary key be the person ID. Okay? So it's kind of interesting here. So normally what we would have done is we would have had a person ID in the driver's license table, but that would not have been a primary key. It would have been a foreign key, right? But if we had done it that way, that would have been called a one-to-many relationship, right? We've seen that before. If we wanted to make this a one-to-many, we would have inserted a driver's license ID and a person ID. The driver's license ID would have been a primary key, and the person ID would have been a foreign key. Okay, that's how you create a one-to-many. But we don't want to create a one-to-many. We want to create a one-to-one. So that's how we do it. To create a one-to-one, the driver's license table has a person ID as the primary key. So we put in person underscore ID, int 11, primary key. Now, the other curveball difference here is that I did not put auto increment in to this particular table. And that's very important as well, because we don't want to consider this like a regular primary key, because it's not. It's actually a foreign key at the same time. So it's both a primary key and a foreign key at the same time. So because it's also a foreign key, I don't want it to muck around with my data. I want to make it so I actually have to manually insert the actual person ID that is related to this driver's license row that I'm creating. So again, we don't want to put auto increment in for this particular person ID, because we're not arbitrarily creating rows here. We are putting rows into the driver's license table because they specifically have a person tied to them, and we want to establish that relationship. So it's a little bit confusing, but it makes sense once you start, getting into the swing of these relationships and understanding exactly how they look and how they work in terms of the actual layouts of the tables themselves. So we create the table driver's license. The first column is the person ID, int 11, primary key, boom. So now you put a comma in, and then we can put all the data that is associated to a normal driver's license. So this is where there's not really too many other curveballs. So we have a license number. We can make it a varchar 20 or however many characters it needs to be. I don't know. I just chose 20 because I felt like it. Okay, comma. I put the issue date and the expiry date. So for these are now no longer varchars. You can actually use actual dates, because sometimes it's important to be able to mess around with dates. If you just make it a varchar, then you don't have the ability to mess around with the date functions. So you can't see if one date is less than another date or whatever. Because if it's just a varchar, then it won't really know how to establish if one particular varchar is less than another one in terms of a date concept. So what I'm going to do is I'm going to create them as a date time type. So I'm going to say issue date or issue underscore date, and I'm going to say date time. And date time is all one word, no underscores, no anything crazy, just date time, all one word. So what that does is it allows me to create an issue date that has both a date and a time associated with it. Now, do you really need the time? Maybe you don't need the time. Maybe you can just say that you're creating it as just a date type. And that's perfectly fine too. You can create it as just a date. But just to show that there's a bit of versatility here, that you can get a little bit more specific, I use the date time type, because then allows you to put in a time if you like. Again, there's no real reason why I chose it other than to show you that you can have a date time object as well as a date object. I'm saying object, I should say column. Object is a keyword with respect to Java. We're talking about SQL right now, so this is just a type. Okay, so we put the issue date is a date time, comma, expiry date, again, it's a date time type. Cool. But we're not done yet. Remember, I said that there's a person ID that we put in here that's a primary key, and it's also a foreign key at the same time. That's very common with respect to the one-to-one relationship. You have a primary key and a foreign key, which are both the same thing at the same time. So how do we create the foreign key? Exactly like we've done it every single other time with every single other table that we've used to create a foreign key. You just put in foreign key, open bracket, person ID, close bracket, references, person, because that's the person table, open bracket, person ID, close bracket. So it's all about what's the foreign key on this table? It's the person ID. Where does that reference, where's the pointer pointing to? Well, it's the person table and the person ID column. Boom, there you go, done. So now we've created our two tables, the person table, the driver's license table, and we've made sure that we are enforcing automatically the one-to-one relationship by not inserting a driver's license ID. Instead, in place of the driver's license ID, we're using the person ID, which is both a primary key and a foreign key at the same time. There you go. So now how does that work? Well, let's insert 3 people into our person table. Let's just use the same 3 people that we talked about before. Trevor Page, Jane Doe, Jack Johnson. These were our 3 authors from before, but now we're talking about them in terms of just being people, because they are people. So we insert that into the person table. Fine. Good, great, grand, whatever. Again, they get the person ID 123. Trevor Page, Jane Doe, Jack Johnson, 123. Now we insert into the driver's license table, right? So here's the difference. When we're inserting into the driver's license table, like I said, we have to insert the person ID. We're required to insert the person ID. It's not going to arbitrarily choose a person, because that would be disastrous if we were to just arbitrarily choose a person ID based on an auto increment type. So let's say if I inserted my driver's license number, so whatever my driver's license number is in real life, P1234567, whatever the heck it is, if we inserted that into the table and it arbitrarily picked an ID, let's say the last ID that was inserted was like 5, so now it's just going to insert 6, that would not make sense, because I myself am not person ID 6. That could either be someone else, or maybe that's no one. Maybe there is no ID 6, so then we would get an error saying, well, your foreign key doesn't match up, so that's an error. We need to specify the person ID explicitly. So I have to put that in there. So when I put in my driver's license number, whatever that number may be, it doesn't matter what the number is, I also have to say the person ID is 1. Okay? The person ID 1 maps back to Trevor Page. So I'm telling it to put in 1 as the person ID. And then I give it an issue date, an expiry date. The format I use is just, the year, so four digits of the year, hyphen 2 digits of the month, hyphen 2 digits of the day. So year, month, day, boom, boom, boom. If I wanted to, I can also put in a time in the format of, hour, colon, minute, colon, second, or something like that. So, but I mean, in this case, I'm not going to, so all it's going to do is it's going to insert the date, and it's going to insert the time as midnight. It just starts at 00, is how it does it if you don't insert a time and you specified it as a date-time object. So that's a good little piece of information, tidbit to know. If you have a date time and you don't specify a time but just a date, it chooses arbitrarily, chooses midnight, so the very beginning of that day, as the time for that particular date time object. Unless you specify a time like 12, and then it'll put in the date and the time as being 12 p.m. So there you go. Good to know. So I put in I can put in my 3 different driver's licenses. So one for Trevor, one for Jane Doe, one for Jack Johnson, and I explicitly say which person ID each of those licenses map to. Okay, I have to do that on purpose. I need to explicitly say which one belongs to which person. And there you go. Because now think about that. Once we've inserted that data, that's the primary key of the table. So I can never insert a second row. Let's say I create yet another driver's license number. I just create one off the top of my head, put it in the table, and then try to associate that with Trevor Page. The database is going to reject that row of data. It's going to fail, and it's going to say, what the heck are you doing? There's already a row that exists with the primary key of 1. It's already mapped to Trevor Page. Trevor Page already has a driver's license number. Why are you trying to insert a second one? So that's the kind of automatic enforcement of these rules that we're looking for. That's what we want to get out of our database, because sometimes us as programmers and humans can make mistakes, or we can have bugs in our code that try to do bad things with the data. When we have the database set up like this to automatically enforce these rules that make sense, then we're never going to have what I'd like to call corrupt data. We're never going to have a situation where Trevor Page happens to hold 2 different driver's license numbers at the same time, because that, like I said, should never happen. One person should never have 2 different driver's license numbers. Again, in Canada, that's how it works. I think that's how it works in the US. If that's not how it works in your country, then okay, I apologize for that bad example, but that's how it works in North America. So that's how I'm putting it into these tables now. So you see how that kind of works and how that automatically enforces the relationship using the primary key and the foreign key at the same time. So because it's also a foreign key, it also disallows you from inserting a driver's license into the driver's license table without a corresponding person. So let's say we have 3 people in our person table. Like I said, Trevor Page, Jane Doe, Jack Johnson. If we try to, so that's person ID 1, 2, 3. If we try to insert a 4th driver's license and assign it to person ID 4, it's also going to fail and say, what the heck are you doing? There is no person ID 4 that exists. So you're trying to insert a driver's license number and associate it with no one. Like I said, that is not a valid scenario, and the database will automatically enforce that for us. So that's pretty cool. And anyway, and I also have a little select statement in there to show what the data would look like if you did a select, and it shows you the which person is associated with which driver's license number. Okay. Maybe in the next episode I can talk about those select statements and how they work and whatnot. That might be a good episode to talk about. Hopefully be shorter than an hour long. I didn't mean for this to be almost an hour long. I apologize. But there you go. That's good information. I hope you guys learned a lot there. I love teaching this stuff. This is what I live for. I love recording these podcast episodes. And fun fact, hopefully today, sometime this afternoon, on the day that I'm recording this, I should be receiving some new podcast gear. So I'm going to be receiving a new podcast microphone. I'm going to be having a real professional setup where I have like a mixer and a whole bunch of cool stuff going on for my actual podcast setup. So I'm going to sound a little bit more professional, and it's just going to make me, as well as interviewing other people, so bringing other people on this podcast, it'll make that process a lot easier, because when I interviewed people previously in a lot of the other episodes that you guys loved, there was a lot of post-production editing that needed to go on because I wasn't using something called a mixer. In any case, very boring for you guys. You don't need to know about that stuff, but very cool because I'm going to be getting this equipment. And what that means is it's going to be a lot easier for me to interview other people and bring them into the podcast and talk to them. So cool. So before I go, I just want to let you guys know that I'm getting pretty heavy on these workshops that I'm putting on now. I'm really liking to do these workshops, which are live online workshops where you can go sign up for them, and I typically have them on, right now it's on a Thursday at around noon. Maybe I'll shift that to be Thursday at like 1 p.m. or something. Again, this is Eastern time. But in any case, if you're interested, I'm putting together these workshops, and it's usually on a different topic each time. So right now, I've run 2 so far, and they've both been very, very good, very fun. People have loved them a lot. I've received a lot of positive comments and feedback from them. So if you're interested, right now, when this particular episode goes live, if you're listening to it on the day it comes out, I actually have a link on my blog. So if you go to howtoprogramwithjava.com, and you scroll to the top, or rather, you don't need to scroll to the top, it'll be on the top, you'll see this little bar that talks about the workshop, and you'll be able to click on, there's a little link that says click here or whatever. You can click on it, and it'll take you to a replay of one of my live workshops that I put on. So again, right now, if you're listening to this live when the day it came out, which is probably going to be May 24th, then you'll see the link. You can click on it and you can check out the replay of a workshop that I put on, which is pretty fun. If not, if you don't see that, then what you'll see is you can click on it and you can sign up for my next workshop. So you're gonna be able to sign up for the next one and participate. And you come in, you just use your computer, you log in, you sit down in your nice comfy leather rolly chair, whatever you may have in front of your computer. You sit back, relax, you listen to me teach you a particular topic with respect to Java programming or whatever the case may be, and you can interact with me, ask me questions, I'll answer them on the spot. Plus, you'll hear and see a whole bunch of, you'll see a bunch of other people in the chat room I have that I sort of built into it, so you can type and talk to other programmers who are live there with you online, watching me as well. And, we can crack jokes and just have a fun old time while we learn about some topic with respect to programming. So these things are a lot of fun, so I'd really recommend that you go to howtoprogramwithjava.com. When you go to howtoprogramwithjava.com/session 45, you'll also see, I'll have it on every page, you'll be able to see that the bar on top, and you'll be able to click on it and either check out a replay or sign up for my next workshop. So that'll be fun. I think, my next workshop, I might do one on object-oriented programming in general, so talk about some object-oriented programming concepts and need to knows and that kind of thing, reminders and stuff like that. So if you've already learned about it, it'll be a good review. If you haven't learned about it, then you're going to be learning a lot. So that's probably going to be my next one. But like I said, the topic will change probably every week. So just keep an eye out for that. If I don't happen to be running those anymore in the future, and you can't see where to sign up for those and you would like to sign up for those, then shoot me an email, info@howtoprograminjava.com. I always like to hear from you guys and hear your feedback about anything at all. I love it very much. I love you guys. You're such a cool, attentive, and interactive audience, and I'm so blessed to be able to have this kind of impact on you guys. I love to do it. So anyway, clearly you guys realize that, so I will stop talking about it. So yeah, I hope you guys hop on over to howtoprograminjava.com/session 45 for all the show notes, for all the code that I was talking about, and to sign up /hear my next or previous workshop, because those are going to be real fun in the future. Alrighty, as always, take care guys, happy learning, and bye for now. Peace.
Thanks for listening to the How to Program with Java podcast. Please visit howtoprogramwithjava.com for more useful Java tutorials.